All right, welcome to another week of OS Dev Gardening, where I embarrass myself live on the internet as I try to work on this OS. I actually made a decision that I want to do like some C programming, or maybe try to do some C programming today. For the last like 9 episodes of this, I've been working entirely on the build system, and I'm kind of tired of that. Like, it was interesting work, and I did enjoy it, but I'm feeling a pretty strong urge to actually do a bit of real development, and write some C code. So that's what I'm gonna kind of try to aim for today. The problem, though, is I'm not skilled enough at the OS to exactly know what to do. I have a few options I can do. I mean, I could go look up the XV6 like homework and stuff like that, which is on the MIT website. Um, because again, I'm just like using this XV6 OS, which is public. So I could do that and like maybe do some homework or something like that. I'm not sure how fun that feels to me also. Um, Another idea I have is just to kind of find my own thing to work on. I have a few ideas, like I think some easy exercises I could try are just like map some page of memory into like user space processes or something like that. I don't know, something like really dumb, like um, what if just all processes had like a page of memory that was just like shared memory, and you can just, I mean, that's even maybe a little bit more advanced. What if every process on the system just had a random page of memory that was just filled with like twos or something like that? I don't know, that's like kind of a dumb idea, but that would be maybe a nice like little exercise, I'm thinking, because I don't have experience with that. And I could, that seems doable to me. Another idea that seems kind of fun is like implement some kind of like basic proc or something like that, where a user space process can somehow introspect itself and get some like kernel statistics about, yeah, what its process, yeah, what it, yeah, stuff about it as a process, like, I don't know, slash proc, like maps is the obvious example of a very useful thing. One problem I have, though, is that I don't actually know what is there in the OS. I don't have a strong understanding of what is already implemented versus what is actually open for development. I would be very interested to work on some drivers too, and I don't really know what devices are available in Quemu to write drivers for, and I don't really even know which drivers already exist. So I'm thinking today it might be a little bit. I think I'm just going to start off with like reading some code, and and just trying to get an actual better understanding of what's happening, because I don't quite feel ready to like really do legit hacking on features and stuff. So I think I need to ease into it a little bit more by just reading through the code, doing some understanding. And once I do that, I'm going to have a better sense of what gaps exist in the system where I could maybe work on stuff, or maybe I could find a bug. That would be cool. Um, find a bug in the OS. That could be kind of fun, actually. I don't know. Maybe I don't know how hard that would be. Yeah. So that's my feeling for today. I think I want to just let's just start. I'm so curious about the virtual memory stuff. I would love to learn more about that and have some more practical experience with that. So let's start with the virtual memory. I want to just, yeah, I want to like be able to trace through trace through page table setup, understand page table manipulation. Is mmap supported? How are processes created? And the virtual, these are just my immediate questions. Oops, huge scary unknowns. These are just my immediate questions that I have. Oops. And maybe we won't even write code today. Maybe we'll just do learning. But that would be fine for me too, because I would set us up for doing some development in the future. But yeah, one of my original reasons for even doing any of this is that I want to understand virtual memory better, and I've always been like a little bit patchy on really how it looks to, be doing page table stuff in actual code. So yeah, I mean, is mmap supported? That would be a pretty revealing thing to start off with. Also, is process created? Would be interesting just to see, how that would reveal a lot about the virtual memory. I'm just gonna start with this is mmap supported thing. I'm kind of curious about that. I feel like it has to be. I mean, it's not. I didn't find it. Where are all the syscalls listed? Okay, yeah, actually, so. Okay, so mmap, okay, that was easy. No, mmap is not supported. No. What else? Yeah, just out of curiosity, what even is supported? Fork is supported. Exec. Kill, interesting. There's some kind of basic signal implementation pipes are supported. Chudder. That is interesting. Chdir. That's a syscall? I guess I guess I never really have thought about this too much, but let me just get my browser open. Chudder. Yeah, it's a syscall, change the working directory, of course. I mean, yeah, I would be interested to do a little micro digression just to see how that is implemented. That's not even related at all to anything that I was just talking about, but I'm curious where the state is. Like, where is the current directory state stored for a process in this OS? So there's this like my proc thing, which is kind of interesting. I don't really get this somehow. Don't understand that. It's like some kind of global. It's like every CPU on the system somehow maintains like some kind of like global. Oh wait, no, I'm being kind of stupid. My proc. I think there was some other like per CPU stuff, but obviously we want to access the process's state. So like, and this is like the process's state. uint. Interesting. Size. So this is a pretty important struct. Actually, this is a really key struct. Struct proc. I wonder if this is kind of the equivalent of task struct in the Linux kernel. Interesting. So with proc.h with some process. Ooh, embryo. What is that? Zombie. Context switching is interesting. Yeah, we need to store all these registers and stuff. Yeah, it look like today might be just a bit more like reading some code together. But yeah, so this is what I was thinking of. There is the per CPU state, and I do not know anything about SMP or symmetric multiprocessing, or how that actually works on an OS level. Push CLI nesting, int enabled or interrupts enabled before push CLI. There's all this like CPU stuff, and then every CPU can optionally have a process pointer to a process that's running on this CPU. I would also be just interested in kind of what it would take to get, I don't know how easy these ideas are, but like kernel threads, if I just want to like have some kernel code that's executing in a thread, can I do that? Like, is that supported? Yeah, I'm kind of curious about that. I don't know enough about that. But yeah, I'm already enjoying this a bit more than working on makefiles. Okay. Structure n CPU. Maximum number of CPUs, param.h. Kernel stack size. Maximum device number. This is just like random constants, I suppose. Eventually, I kind of want to do like an overhaul of the syntax and coding conventions, like with the naming and stuff like that, just to make the project my own a little bit more. But I'm not gonna do that now. Anyways, this is interesting just to read through at least. Process state. Process state. So this is our virtual memory stuff. Proc state. Bottom of kernel stack for this process. That is interesting. Yeah. Size of process memory. Parent. Process. Trap frame for the current syscall. That's interesting. Yeah, I'm kind of just following my curiosity a little bit, but trap frames. My understanding of trap frames is that it's like this kind of CPU context that gets pushed onto some stack when like an interrupt happens, something like this, and it contains some register context, I think. Yeah, it contains some register context. Oop, 20-second break. Okay. Trap frame built on the stack by the hardware. Passed to trap. We could look in the Intel manual if we wanted to learn more about this, but just a trap frame. Yeah, it's like some register state and some stuff, and then when you want to return back from the interrupt, I think you like do stuff here. Like you can set EIP, for example, Although, yeah, this is interesting stuff. I don't know the details, but I would like to. But yeah. So interesting. Okay, so my guess would be that the rough flow looks like user space is running. User space triggers an interrupt to do a syscall. The CPU does its interrupt stuff. It pushes a trap frame onto some stack. I don't know which stack. Like probably the kernel stack, but how does it know? I don't know. Because at the moment the interrupt from user space happens, the stack pointer is going to be a user space stack pointer. And it feels weird and just very wrong for some reason for the CPU to be pushing it onto the user space stack. So I'm thinking that it's going to have to be pushed onto the kernel stack somehow. But that is just, yeah, something I don't know. Anyway, some context. It's just more register context for task switching a thread, sleeping on Chan. If none, what is Chan? What is Chan? How? What is? It's something. Sleep on. Channel? Is that what it stands for? Although I don't. Sleep on Chan. Oh man, I was hoping my oh cool, oh nice, it did work. What does it look like as a call? Sleep. What is B? Okay, I think so. This is a void pointer. I think it's a context struct that callers can pass in for some kind of context. You can pass in anything you want here. Okay, yeah, I don't know. Chan, okay, I don't know. Maybe I won't get too tied up with that, but yeah. Sleeping on Chan, okay, whatever. Killed, were we killed? Open files. So yeah, okay, got us a whole big bag of stuff, and then here is our inode. So that's really what it is. The current working directory is stored in here in the process struct as an inode pointer, which is interesting. So just to check out the implementation. Also, what? Chidder takes one argument. arg stir. Interesting. How does this fetch the nth 32-bit system call argument? Oh, okay. I was wondering, yeah, it uses this global state again. Which I don't love, but maybe, maybe there's a reason. Maybe it's super convenient to have this global state accessible like this. I think the Linux kernel has this also, and I mean it's a global mutable variable. So that, for all that's problematic for all the reasons it's problematic to have global mutable state. I wish I understood this. This function takes no arguments, and it pauses, interrupts, gets my CPU, caller being rescheduled. Okay, that's low level. It gets my CPU, which means what? Read E flags. Call interrupts. Interesting. There's a E flags has an interrupt flag. Now that is interesting to me, and I am going to actually be prompted to open. Oh shit! Open. Did that work? One second. I'm actually interested enough to look at the Intel manual and figure this out. E flags, system programming. Maybe it's in the basic architecture. E flags. System flags. There it is, the 9th bit. Yeah, so I am very unfamiliar with the system flags because I've never needed to look at them. The normal flags that everyone's familiar with is the normal E flags that you there it is. A nice picture. Yeah. This is all the normal stuff you do in user space. But then then there's like all these interesting system flags, virtual interrupt flag. And I guess that's just like global, or it's just like global CPU state, basically. Interrupt enabled flag tells you whether interrupts are enabled, probably. Controls the response. Set. Okay, is that actually what I was looking at though? Read E flags. Interrupt enable. Well, sounds about right. And that wasn't it the 9th bit? That does this 2 is not the 9th bit, is it? It's not the the 10th bit or index 9? I don't know. Is this indexed? Yeah, okay, this is indexed, so it's like index 9, right? Controls the response of the processor to maskable interrupts. Set to respond. Cleared to inhibit. So you can also just control interrupt. Oh. It should not be modified by application programs. Okay. I didn't even think it was. No. Is it even possible to modify this from application? Surely not. It's a bit of a digression. There are no instructions that allow the whole register to be examined or modified directly. When using the whole TSS stuff. Yeah. Okay. Anyway, that's interesting. So how do you, if you can't read E flags, how do you read E flags? Push flags pop into this thing. Okay. I don't know what it meant by that in the manual then, but okay. That's cool. So my CPU. So this is basically just an assert. Speaking of asserts, I mean, it would be cool to have an actual assert macro. I kind of want to try to make one because it would be useful to have like a macro that's like, I'm going to call it GDN assert for garden assert. That's just like read E flags. Then this would need to be the opposite condition. Which is kind of ugly. Like GDN assert read flags. If that, this is testing if the bit is enabled. So I want to test if the bit, I want to make sure the bit is 0. So I would need to like mask it or something like that. Yeah, be like read E flags and invert the bit mask equals 0. I don't know if this like, it's been a minute. I don't know if this is exactly right. I think it is 0. Something like that could be cool. Why not? So let me try. Yeah, I don't, yeah. Are there asserts already? Static assert. Wow, this is how you do static assert in C, apparently. What is this even? Compile time asserts. Static assert. How does that even work? It takes two things, the condition and some text, and it emits a switch statement. with the condition in a do while loop. So there's normal asserts, but makeFS is oh, interesting. makeFS is weird because it's a user space program that runs on the host, so it's not in the OS. Yeah, I'm just gonna do this. I might need to ask ChatGPT exactly how to do this though, but it's gonna be something like define assert message. And what am I trying to write? How do you, and then I want to basically, okay. Yeah, how do I actually do this? I want to basically omit this. I'm just kind of getting messed up with the whole macro syntax. So if not condition panic message is this right? Also, oops, what? Are there any other good defines I can look at here? Defines this call. Define, blah, and then just use backslashes if you want to put on new lines. I think this is mostly right. What is going on? I think what's wrong? Cond is undefined. Oh, oops. That'll do it. I don't know. Let's see if this works. I feel like I want to do a quick test in Godbolt. Just to check my bit math is right. Yeah. That's kind of a basic task, but let's just do that just for fun. Int main. Okay. And we're going to have a variable int x. Okay. We're gonna have our variable, and then we're going to have our like mask. What was it? It was like this, I think. 9th indexed bit. Something like string. Oh, oops. Is set or something like that. And then the easy thing is like if and mask. That's easy. Yes. Execute the code. Okay, and it didn't. It's not set But if we then set this to like hex, XFFF, I'm really hoping it should say mask is set. So now I want to basically do the opposite. So now, this is bitwise stuff 101. 0, mask is not set. Mask is set, right. Just to double check and think that through. So we have X, which is our variable. We have our mask, which is like the single bit we want to check. We're going to flip everything. Oh wait, no, that's wrong. Wait a sec. No, I'm being dumb. Yeah, no, I'm being stupid. We want to extract only that bit. So if we have like a bunch of stuff, we want to AND everything else with 0. Yeah, I think, man, yeah, no, not my, okay, and then, yeah, so when we mask it, we just get the thing that's there. And we can then check if it's something there or not. So yeah, I was being kind of slow. So it was 0, mask is not set. All right, yep. Right. Go ahead and assert. So now low key. If I yeah, oops. Ugh. Did that actually just recompile it? I wanted. Does it automatically? Yeah. Okay. Good. So, but what if I, to test my assertion, what if I'm like, I want to assert, this is going to fail, but like I want to assert that the flag is set when we call make CPU. What happens then? Okay, nice. Booting from hard disk. Panic. Awesome. I feel kind of good about that, actually. That's kind of cool. So now we have like this little assert macro. I am just curious how often this pattern is used, where we do an if statement. Oops. What? Oh, there's a space. Oh, okay. Wait, yeah, obviously there's a space. Oops. Followed by a followed by a panic. B1, does this do what I want? Yeah. So all these places are places where we do a check and then panic on the line after. So theoretically, all of these places can be converted to our assert, which is kind of cool. I kind of want to do that. Yeah. Yeah, I kind of want to do that. So we'll just, yeah, like finally my first line of C ever written for this OS. Yeah. Yeah. So I think in order to really productionize this, ideally this would be in its own header. What do I call that? I'm gonna call that like new file, advanced new file. It's gonna be called assert.c. Assert.h, what am I talking about? Assert.h. What are the other headers? The other headers are just like these random things. Yeah, assert.h. Why not? Nice. Yeah, technically it depends on panic. Yeah, technically it depends on, I actually don't know. How do I jump to this? Console. This is also interesting. I was also wondering why it only appeared in the console and not in the serial terminal. Not here, it just hangs. That's actually an improvement I would kind of like to do. Yeah, nice. That should be hopefully not too hard to do, but maybe first things first. So there should be a oh man. I can't jump to headers. I need to semantic. How do I not have that? I do have it. What? Switch. Oh yeah, okay. I just need to set a key binding for it. Or wait, is this? Wait, no. Sorry, I messed that up. I naturally wanted this. Wait. But now it's working again. Reset. Move key binding. Command Option O for some reason is doing it. Whatever. So yeah, there's a header. Oh, what the hell? This is completely going into the wrong place. Why would you go all the way into this totally wrong place? Okay, I'll have to fix that later. Is there no, there has to be a console.h. Otherwise, how, when you call panic, ag panic, man, that's annoying. Is it a defs.h? What is defs.h? Well then, that is so interesting. Rather than making header files for every C file, there is a single header file that contains every, what? Man, no, this is, yeah, pretty odd. Slightly more convenient because you don't need to make files, but what's the downside of this? So now every translation unit that wants to call like some function somewhere only needs to declare one header, one include for this whole thing. The downside is that anytime anything in that file changes, you need to recompile everything basically. I think, oops, just to help me understand, I'm going to try to illustrate it. So let's say we have a.c, you know, if all these translation units, call it b.c, call it c.c. One second, I'm just going to plug in my mouse. Okay, call it d.c. These are all including defs.h. And on the other end, we have like, you know, vm.c and all these like kind of like libs or whatever. These are these other C files. You know, we can take a look. Bio.c console. It's like whatever. Bio.c console.c. And this is the header file that all these prototypes are declared in. It's kind of interesting. So in like bio.c, yeah, this is like, so it kind of looks like this. This is the shared header file, which contains all the prototypes for all these C files. And then, you know, for any other C files that need, if a.c needs a function in console.c, it includes defs.h. If b.c needs something from vm.c, this is like the single header file for absolutely everything. The convenience is that when you're developing code and you want to add like a new file, like a new thing here, you don't need to create a new header file for your C file. All you just do is add stuff to defs.h, and then your new user that wants to use this thing you just added, it might already have defs.h, and it can just use it. The downside is that every time the header file changes, all the translation units need to be recompiled. That's just how C works, because you might have, like, it's a dependency. The C file depends on the header file. So the C file is depending on type definitions and struct definitions and variables and whatever that's in the header file. And so when this changes, everything downstream needs to change. And so the disadvantage is that anytime you do a change to any of these, even just one, that is, anytime you make a change to any of these, that causes a change over here. I think that is the key thing. Or is it? Yeah, at the very least, yeah. So if you add a new function, for example, that's meant to be exported to clients in any of these, you're going to change here, and then all of these things are going to need to recompile. Even if this thing only uses one function from console.c, if you add a function in vm.c and export it to clients used over here, this guy still needs to recompile for no reason. And this doesn't matter if your code base is small, but if your code base is big, then compile times are actually a topic to care about. So that's, yeah, the whole include hygiene is an interesting topic. Unit headers. So a more hygienic approach is to have a header file for every C file generally. But it's interesting because there's like some exceptions to this. So I don't know what the deal is with defs.h, but Anyway, I was looking for where panic. So, and it's right here. So I was on this goose chase looking for console.c when it's in defs.h, and then randomly this weird other console.h appears. But what I also want to do is add support for panicking and sending messages to the serial console, as opposed to just the VGA oh wait, no, what's going on? So this is the console, but nothing appeared here. So what is this? Is this is the console too? I'm actually kind of confused. Yeah, I don't I think I panicked. Print to the console to draw attention. What? So, okay, I'm confused. I'm confused because I thought this was the console, and I don't see a panic message here. Whatever. So that's a mystery. I don't know why it didn't appear in the terminal, but it appeared in this this Kimu window. Anyway, my goal was just, okay, here's what I'm going to do. I'm going to make console.h. Advanced new file, console.h. Put all this stuff here, take it out. Let's see if this works. This is just, yeah, some cleanup. Now console.c. I'm going to test if my Clang formatting works. It doesn't. Oh wait, I disabled something last time. I forget why. I was working with CMake or something. So now I've got my console.h, which I'm going to put on a new line because I've heard that's kind of a nice convention to put the header file for like the translation unit on a different line. Now the question is, are any of these things from defs.h needed anymore? Which is kind of an annoying question to answer. I'm getting too many tabs open here. All right, goodbye. So my question is, is this necessary anymore? Can I remove this include? And in order to answer that, I need to search for every single, I think it's highly unlikely that, or you know what, or I can just remove it and make the compiler tell me. Although that's not foolproof necessarily, because there could be indirect includes. So like I could remove it, and maybe this C file relied on something actually in here. I don't think that's the case. Like this, or maybe IO APIC. Yeah, actually, yeah. That's the thing. And that's also a problem with this whole defs.h global thing. It makes it very hard to tell what it like what's actually needed from this thing. Because it's a massive header with like so much stuff. Anyway, for the moment, we can just do this. And so the other thing that I need to watch out for are clients of any of these functions, because strictly speaking, they need to now, come on, search. Any C file that calls any of these functions needs to now include console.h to be hygienic. Okay. C printf. Yeah, it's a lot of clients. Okay. exec.c. I feel like I should save this into a register or something like that. Oops, no, not get rid of it, I think. Save it. Right, so now if I do, yeah, good. So now I have it in my register C, so I can easily access it as I go through and clean up all this stuff. Interesting. Wow, interesting. My Clang format is so intelligent that it actually knows to prioritize the header file of the translation unit first in the sorting. That is very cool. Interesting. So now, yep, IOAPIC, main, we already did that. Proc. Oh. Can I drag this here? Yeah. Proc, oops. Syscall trap. Yeah, this is gardening. This kind of work is gardening. And that's a nice, yeah, nice easy introduction for me as my first modification of C files and stuff like that. So yeah, this work might conflict with the build system work I was doing in another branch, but whatever. Yeah. Okay, so I officially did everything. Okay, so step one is going to be this stuff, right? Include console.h, console.h, move this stuff there. What about defs.h? That should have, did I miss that? Did I not save that? I did not save that. Defs.h. You know, I kind of prefer fork actually for looking through this stuff. So yeah, console.c, console.h, defs.h no longer has that, and all of the previous, oh wait, but I'm not done. I need to go back to console.h and keep going. Hello. 20 seconds. All right, I feel like this stream could actually be called OS Dev Improv or something, because I just have no idea what I'm actually going to do when I sit down to work here. Like, I planned to do virtual memory, and then now I'm on this wild goose chase with asserts, and then now I'm cleaning up includes. Okay. Oh, uart. Okay, uart is different from console. That's the thing I was getting confused. The uart is this thing in the terminal. The console is this thing. Yeah, I don't... The reason I was confused is because usually when I hear console, I think of serial console, which usually means uart. So, or which often means uart. Right, got this one already, good. Clean up some of this, then panic. Now this is gonna kind of suck, because this is used very widely. And now I want to update all, well, okay. This is used very widely to manually panic. But a lot of these I'm going to later change to be asserts, actually. So it could potentially result in a lot of unnecessary back and forth if I like edit all of these to add the include for panic and then add the assert, then add the assert thing, port these all to asserts, and then remove the was it console include. Yeah, but so many, all of these are asserts actually. All of these are asserts. So many of them, I think I'm not going to do that now. It's kind of, it would be too much of a pain, I think. I wish I knew a better way. Like, what would be the fastest way to add the include for all these files without manually doing it? It would be so great if I could make a command line thing that adds the include for me, but I don't actually know what terminal command I would use to insert the include console.h into like the right place in the file. But you know what? It's not actually that many files. So it's not actually that many files. What? All right, whatever. I'm just going to do it. So it's going to become console.h, right? We haven't touched this file before, but it uses panic. So yeah, file.c. No, oops. Nope. File.c, fs.c. Console.h is already used. Nice. Why? I don't know. I guess I'm sure we just did it. I can probably look. fs.c. It was for, I don't know. It was for one of the other things. One of the other this thing. IDE. kalloc. So that would be, I'm just going to write this down. So it'll be another task, another easy task. I'm just going to keep this here to make panics appear in uart also. You know what? I should just add it here. Okay. Make panics appear in the uart. All right, give me 1 second. I'll be right back. Yeah, that is going to be, whoa, into unnamed use log. That UART thing is going to be a nice, like a great beginner change that I can make. Log.c, console.c, memide, panic, whatever, proc.c. We already added it, I think. Yeah. Sh.c. All right, this is like the maximally rigorous way to do this is with like the includes and stuff. Ooh, did I mess something up? I think I did. Oops. I only meant to add something. Okay. This is the maximally rigorous way to do this. What happened with my Vim thing? That's weird. Trap.c, panic, trap, already got it. Already got it. So now, great, so now we're like kind of a bit more include clean, which feels good. Yeah. So the step one, again, move these things into this header. Now every client that used any of these things is now updated to include console.h. And technically I should also be checking for every single one of these whether defs.h can be removed. But that's very difficult. That's so hard because I would need to check if any of those functions are used in that file, which is more work than I'm willing to do at the moment. I do not want this. Not want this. And so, yeah, let's make a branch. What is this? Add assert macro. So what are we doing here? We are, yeah. Prototypes. Move H. Move console.c prototypes to console.h. This is in preparation for adding an assertion header, which depends on panic, which is now in console.h. Technically, the assert.h could have depended on defs.h. But I don't want to perpetuate this defs.h thing, which is just not good code to me. So now our assert.h, we can, yeah, include console.h for panic. Also, holy formatting. Is this really how it chose to format this? I'm also realizing something a little bit interesting. So when I did this garden assert thing, I'm actually a little bit surprised that it compiled, because the garden assert macro the garden assert macro already has a semicolon that gets emitted, and now I'm adding a new one. I should probably have checked if it compiled. How do I have... Yeah. Make kernel. Right, okay. Got me. Now we get to include assert.h. / new line at end of file. Holy, what? Are you serious? What do I do? Do I have to... What just happened? Oh, now I removed that. So your last line of the macro does not have the / new line. That's why. Cool. Interesting that it puts it all the way over here. I guess that... Yeah, maybe that's a good thing. Make key move. And our stuff is still crashing because I'm asserting the wrong thing. This should be equal to 0. Oops. Somehow my shit got linked. I don't know how that happens. Okay, make kimu. Now we're running again because our assert is correct. That's kind of cool. So I'm going to actually do it. Nice. Oh, that's so ugly. What kind of line spacing do I have right now? 80. Clang, you gotta be kidding me. Column limit 80. Oh, that's so sad that it's 80. Ugh. Well, I don't want to change it right now, but I will change it later and reformat everything. Okay, too bad. That's so ugly. Can I make it shorter somehow? Like, read E flags. You know, I could do this. I could do that. Maybe I will do that. Just because it's less ugly. It's a little bit less clear to me. I do like the =0 clarity, but yeah, whatever. Yeah, okay. Well, how long have I been doing this? An hour, 14 minutes. Okay, cool. I can go a bit longer. I'm actually really deciding on this thing. Yeah, I gotta be honest. I mean, I find the equals equals zero clearer. When I see the exclamation point, my mind's like, my mind takes a little bit more energy to figure out what that means. Whereas if I just see this, I immediately know that, okay, E flags and this bit mask, so get that bit, and then now what? Check if it's zero. And assert that it's zero. So yeah, okay, whatever, it's ugly. I'll reformat things later maybe, yeah. Assert proc. So now, from a Git perspective, this is all I need. I can just commit this. Add gdn assert. Yeah. Yeah, I think that's good. And then now I can, if I wanted to, I could actually convert things to using the assert. This might be a bit annoying to invert every single condition and make sure I did it right. But yeah, why not? I mean, it's a lot of places that might be kind of boring to actually do, but this is kind of like my first step of taking a little bit more like ownership of the code base and putting a bit more of myself into it. So yeah, call this interrupts enable. I can probably write a macro. From that perspective, maybe it's better. My macro is just going to do this. It's just going to take whatever is already in an existing thing. So what was it? Ag history merge. Ag this thing. All right, let's. No, but no. Okay, I was going to say, like, what if I was just kind of lazy? Panic. For example, assert. I could just slap a not around this whole thing, but that is not going to pass code review. So so the assert is, we're going to, if it's greater than or equal to block size, panic. So assert that it is less than block size. Right. Why is this giving? Oh, oops. But I never actually fixed that thing I was talking about, because I believe that now our code is going to have 2 semicolons, which I didn't even know is valid. Can I do that? Yeah, I guess I can, but that is weird. I think this is why people use the do while 0 pattern. I'm gonna chat GPT that. Want to make an assertion macro in C. What do I do in the macro such that clients can call it like assert with a semicolon at the end, and so I don't actually end up with 2 semicolons in the generated code. I think this is the do while 0 pattern. Yeah. Yeah. You know, I don't actually. Yeah, I can also spruce up this assert. Really, like, yeah, I can go crazy with these file and line things. Let me do that. I'm just gonna do that. So do while 0. Okay, now my oops. So annoying. Okay. Is that right? Yeah. That looks right. Panic. Message. Okay, so if I wanted to get fancy with this like whole like underscore underscore file line thing, I would need to construct a string. Or let's see what ChatGPT said. The way they do it is, yeah. So they're able to call like fprintf. Here I'm calling panic. Console.c. It would be kind of neat if panic could take a format string. What? How is S used? Oh, these single letter variable names. Right here. That's where it's used. It would be neat if this could be somehow variadic and then forward the variadic arguments to cprintf. I actually don't know how to do that. I'm not going to worry about that for right now, though. It could be a to-do. I could add a to-do. Yeah, why not? To-do. But just real quick, I just want to... What is this? Okay, no, this is... I want to quickly check what it... Dang. Can you not add... Sheesh, what happened? Can you not add interesting. So what happened? Oh, everything became like, man, this is annoying to deal with. Yeah, that's why macros are so annoying. How do I cannot... Can you not add comments in macros? Because now I would need to add a backslash, but then the rest of the macro becomes a comment and comments out the rest of my code. Well, okay, this looks like to do. Add file and line to the message. Okay, call it. Yeah, so now we have this like really good assertion macro. And it's yeah, it's going to work. It's going to compile. Why did that not work? Implicit declaration. What happened? Okay, no, this is totally expected. Now, for every place I'm doing this, I need to, yeah, do that. One quick test I do want to make, though. I want to quickly revert this back to the more, like, naive form that I originally had it, which was like this. Because I want to actually observe the double semicolon problem multi-line comment. What's the problem? Okay, what the fuck? Okay. Okay, whatever. I want to observe the multi-line comment problem in the actual generated C code, which I can do if I proc. And then what's the command? I think it's capital E. So if I run this command, but do dash E, shit, no. Okay. How to GCC only run preprocessor. That's what I thought. Come on. Standard outputs. Do I have to also get rid of something, like get rid of the dash? Yeah. So now, is that really it? But yeah, okay. Here it is, double semicolon. Okay, I apparently, yeah, I'm still doing this thing. So anyway, that's why it looks kind of weird. It's like a double. Yeah, it's like not blah 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 blah. Okay, panic, but yeah, here's actually kind of what it looks like. If not this thing, then panic. And we have the double semi, or wait, what? Yeah, double semicolon. And then now we go back to our really like industrial strength one. And we're gonna do that one more time. Panic. And we observe that it looks kind of messed up, but this is syntactically correct. There's only one semicolon, and for some reason it's on a new line, which I'm not sure I understand. But I mean, yeah, like the macro emits itself into a single line right here. And then that's just how the macro works. It's just like a single line that goes across, and then it's interesting that this goes on a new line, but whatever. Make kernel. So yeah, that's kind of neat. We have now our assertion macro. We can do assertions rather than if panic, which I think is good. Yeah. And where was I now? I was porting my entire code base assert to use the assert, but it's a 20-second break time. Nice. Interesting. Also interesting. This assert is interesting. Assert a size of struct log head is less than b size. Yeah. I wish I had C++ right now. Like that, there's no reason to be checking that at runtime. That's completely a compile time check, but we're checking that at runtime on the system init, it seems. If you've ever wondered why a computer or a program is slow to boot up, it's because of stuff like this that accumulates and accumulates and accumulates and accumulates, and before you know it, you're doing all this stuff at runtime on the initialization of your program that you didn't know of, or like whatever. So it's like, obviously it's like a super minimal thing just to check this one condition, but it should be a static assert. So when I convert this to C++, this would be a prime candidate for a static assert. Yeah. Moving on. So what? I'm still gonna run a macro for this. I think it's worth recording at Q. So starting from here, I am going to jump here. I'm going to copy this condition. I'm going to go up one line. I'm going to emit gdn assert this thing. I'm going to paste the condition. I'm going to go down 2 lines, jump back to the start of the line, find the string start, copy the whole string, go back up 2 lines, find, escape, go to the end of the string, emit a comma, space, and then paste. Oh, that's such a bad assert message. And then finish with a semicolon, and then end the macro, which produces our automated lazy macro. I'm going to try this out somewhere else. Check that out. That's pretty cool. Check that out. Is that right? So all it does is it takes and it does the dumb inversion, which maybe I'm fine with. Wow. Again with the ugly formatting. Yeah. I'm not sure assertion macros usually take an error message, but yeah, no, seems legit. So now I can go to, and maybe that was it. That's kind of cool. Let's see how fast I can do this then. So the idea is, now that I have this macro, yeah, okay. This is saving me a lot of time, actually. It's kind of annoying to jump around like this, but whatever. I'm not really paying too much attention to this, and right now I'm just going to code review it in the diff later. It's a little bit of tech debt that I'm taking on for like these kind of ugly automated inversions of the condition. Ouch, like that. Yuck, that's gross. So maybe it's worth a little bit of cleanup, like VM. So what was this originally? It was just like if, yeah, so they were doing the pattern that I was kind of not excited about. So I can just do, I feel like there's too many. Oops. There we go. Also, what did I just do? It was assigning PTE. Oh my gosh. It was assigning PTE and checking it. Wow. So one thing I'll also mention about the nice thing about doing an assertion instead of the if, blah, and then panic is that the assertion can be toggled on and off and potentially removed, like, yeah, from the build, like compiled out basically, if we felt like doing that. Yeah, I mean, I'm making kind of sweeping changes here, and I hope I'm not breaking things, but I was actually moving kind of fast. This is an interesting pattern. In order to really refactor this code, it should probably look different. It should probably look like this. Oops, shit. First off, and then shit. I want to edit everything in this like argument. Okay. And it's just like, what was the original thing? It was like, if assert that the PTE is not 0. That's a bit cleaner. PTE equals. Turn 1. Same thing here. Assert PTE is not equal to 0. I think that's right. Yep. Yeah, this is gardening at its finest. Just like cleaning very, very little approachable things up because I have no idea. Oh shit, I have no idea how this thing works still. But yeah, so let's double check that. So if PTE equals blah, 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 blah equals 0, panic. So it should not be 0. So we extract this thing, PTE equals blah, 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 assert that it's not equal to 0. Yeah, I think that's right. Oh, wow, my macro messed up. Ouch. I'm going to need to redo that one. Space, remap. So what was it? Panic. make a copy. Ooh, no reason to do that. But my condition is wrong. So it's saying if something is not equal to 0. So all I need to do is be like, if this should be if it's not equal to 0, if it's not page aligned, then panic. So assert that it is page aligned, right? Good. Does it still compile? Oh, but need to declare my header. Cool. Interesting. So I'm just gonna take some tech debt notes. Oh yeah, so I already kind of got that, captured that here. So vm.c was another one of these header files that is used, that uses defs.h or something like that, instead of making its own, which is kind of weird. Yeah, the auto-generated code looks a little bit weird, but I'm fine with that. Moving on, MP. Multi-processor support. All right, let's look for some panics. And that was it. Quick code review. Is that really the only? No. Proc had some more, right? But log. I kind of can't stand to watch this bad assert. Assert not less than, which means must be. I hope I did that right. Yeah, it's not less than. It's not less than. Must be greater than or equal to. Yep. All right. What else? Anyway, so cleaned that up. Okay. Interesting. If size of log header is greater than or equal to b size, cannot be. Okay. But I'm going to want to amend the previous one. Insert, amend. Okay, good. Oh, not again. Oh. This pattern. Strange pattern of assigning. Or is it strange? I don't know. It seems kind of strange to me, but now it... Maybe it seemed clever at the time, but I don't love it. Oh, okay. Conf. testing. So is this right? If conf equals blah, 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 assign that equals 0, then panic. So assert. So then to extract that, assert that it's not 0. Cool. VM, kind of looked at that already, right? Assert. Yeah, whatever, that seemed right. Dev space. If. Assert. Okay, this is another glaring thing. What is it? VM.c. C. It's online. 191. Assert that it's not. Is that right? If size is greater than or equal to page size, panic. So it must be less than. Okay. These are also kind of bad. 6.3. So that's not equal to 0. Okay, nice. Right? If it's equal to 0, panic. So it's not equal to 0. Again, let's check all these asserts. Oops. Good, okay. It's looking pretty good to me, I think. Proc.c. What other panics can we... It's doing it again. Oh, okay. Assert that page dir is not equal to 0, right? I think so. Right? If equals 0, panic. So assert that it cannot be 0. Not equals. Panic. Okay, these are going to be good. Okay. So this is just becomes this. If it's not holding, the thing is, you need to make sure that you're not actually putting important side effects in your assert in case you ever decide to compile them out. This happens with Chrome sometimes. Like, there's been security issues where someone put an important thing in an assert and then the assert got compiled out. So, holding. Seems That's so funny that there's no reason the int r needs to be there. It can just be, and then mutated. It can be assigned directly there. This does not seem to have side effects to me other than pushing interrupts, which hopefully doesn't matter. So I think it's safe to convert this into an assert. So if it is not equal to 1, panic. So we need to assert that it is equal to 1. Okay. Not moving kind of fast here. That's fine. Panic. No, I'm looking for panic. Panic. Panic, 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 panic. Okay, all the panics don't have ifs. Let's check it out. Assert. That was the original one. If it's 1, the panic. So assert that this thing is equal to 0. Extract out this assignment. And if it's equal to 0, panic. So assert that it's not equal to 0. If it's these things are equal, panic. Assert that they're not equal. If we're not holding, okay, assert that we're holding. If we're not 1, panic. Assert that we are 1. If we are running, panic. Assert that we're not running. E-flags. If this thing is 1, panic. Assert that it's opposite. If it's 0, panic. So it's not 0. If it's 0, panic. Assert that it's not 0. Good. Yeah, this is a bit annoying. Oh, all these call sites to go through. Yeah, I don't have to do this. I don't have to do this. I could leave some of them as if panics. Let me do another grep. How much more do we have to go? It's not that much more. Especially if I go faster. Especially if I go faster and I just say it's okay to use the automated one. And I decide, oh my gosh. I don't know, that clearly has an important side effect. So not all of these are eligible for asserts, which is good. Like that one's not ialloc, sounds like it's allocating memory. If dirlink create dots. This all sounds side effecty. Did the one I convert have a side effect also? It actually did. Yeah. No, I don't. That's not correct. That's the only actually eligible one here. Moving on. fs.c. Oh wait, but nope. I need to assert.h. Assert.h panic out of blocks. Panic. I'm gonna move. Just gonna move fast. Okay. Okay, that's a very complex condition. I might regret this later, but yeah, some of these conditions are hard to read. But I mean, I'm seriously wondering about this one though. Who is it helping to convert that into an assert? That's such a... If IP equals 0. Okay, fuck it, I'm gonna do it manually. Okay, or I'm gonna do it semi-manually. If IP equals 0 or, not holding sleep, or PREF equals 1, panic. So I think I need P equals 0 and holding sleep and IP ref 1. I think that's right. If any of those things are true, panic. So we want to assert that all of them are not true. So IP cannot be 0. Holding sleep must be yes. IP ref must be greater than or equal to 1. Yeah. Okay. 20-second break. So these clearly have side effects. All right, let's reassess. Assert this thing, no side effects. This thing, yep. This thing, no side effects. This thing, yep. Rewrote this thing, yep. This thing is easy. All right, what's next? Mem IDE. .h panic. This is easy enough. Oof. Is that right? No. My macro messed up again. Yuck. If flags equals be valid, panic, nothing to do. So now I need to be like, I feel like, yeah, no, some of this is low risk, but like there is like some risk of me actually messing stuff up here. So I'm going to, okay. Just gonna copy this, paste. If it's equal to be valid, panic. So that means it should not be equal to be valid, right? Right. Good amount of asserts. Okay. No more panics. No more panics. This file. All right. If it's not holding sleep, panic, so holding sleep should not be valid. Should be equal to 1. Should be less than disk size. Good. Console.c. That's interesting. oof. If that or that, so therefore and I think this is right. If pos is less than 0 or pos is greater than this thing over on flow. So assert that pos should be greater than 0 and less than or equal to something, something, something. Good. If panicked. If panicked. Okay, we are reaching the end of the stream, but this is nice. I'm pretty happy. I feel like I finally had a chance to work on some C code, like the smallest amount. Still nothing like too real, but at least I'm doing a bit of hacking. So yeah. So if it's 0, so assert that's not 0. Yep, okay. Moving on, spin lock. That's an interesting one. Spin lock.c panic. If we're holding those, assert. These messages are not very good. So we should be holding this. Okay, more of the same. Interesting. It's not a pen. Okay. So oh shit. Okay. Try to decrement that. Assert CPU CL and CLI. So if it's less than 0, panic and pop CLI. So we decrement it and then check. So assert 0 pop CLI. Good. That's it, right? No more panics. If holding panic, so it should not be holding. If not holding panic, we should be holding. If it's 1, should not be. And then we try to decrement it. And then do a consistency check. Assert that. So it's like if it's less than 0. So quick note. This is actually why it's kind of nice to use signed integers. So it's this NCLI thing. Struct CPU. Can I do this? No. Can I do my CPU? Yeah, cool. NCLI, it's an int. Depth of push CLI nesting. So I think sized types versus unsized types can be a bit of a controversial thing, but I know some people argue that only sized types should be used because using a sized type allows you to actually assert that something cannot be negative. Whereas if NCLI were an unsigned type, then it wouldn't be possible to do any kind of meaningful assertion on it. And also unsigned types give this false impression that they can't go negative or protect you in some kind of way against them going negative. But that's totally not the case. It's actually really easy to underflow an unsigned int because you always operate so close to the border. So with signed ints, you don't operate close to like the edge of the int range, and you can also assert them meaningfully, which is nice. You just need to be careful if you're ever passing a signed type into an API that uses unsigned types, because it gets messy if you pass a negative number into an unsigned type. So anyway, I'm pretty sure that's right. So I'm gonna stage that. Bio.c. Oops. More of this. Nice. Quick code review. If it's not holding sleep, panic. Assert that we're holding sleep. If it's not holding sleep, panic. Assert that we're holding sleep. Good. IDE.c. This is interesting. Quick check to make when console.c. Oh yeah, I think I forgot. It's to spinlog.c. Okay, I forgot it everywhere. Where else? Good. Okay. IDE.c. Panic. Oops. Good. Next, oh, so many asserts. That's a good thing, probably. More of this stuff. This is where I messed up, my macro messed up last time. So I'm just gonna do it manually. Try not to mess it up. Okay, and then this thing. Right? Oops. So if this thing is valid, panic, sorry, let's not be valid. Oh, interesting. Okay, if it's bdev is not equal to 0 and not have disk 1, panic. So I think my condition is going to be bdev equal, I think, this one. Is this right? If both of these true, we have to panic. But if either is not true, yeah, I think, bdev and panic. So if bdev is 0, we're good. Or if have disk 1 is good. Yeah, I think that's right. Okay. Console IDE. Assert that it's not equal to 0. It's less than fs size. Assert it cannot be greater than 7. Assert that's less than or equal to 7. Holding sleep, not, and 0, or have disk 1. Good. Yeah, I hope I'm not injecting too many bugs here as I refactor, but panic. Ooh. also sh.c is not the kernel. I wonder, yeah, all this assertion stuff I'm doing is only appropriate for the kernel because it uses this panic thing, which is like a kernel panic. It would not be appropriate to use that in user space. So is this not? What? What the hell? Oh, it has its own panic. Okay, that's confusing. Okay, so we don't need to do anything there. File.c. I need to actually remove this. Panic. This is kernel, so. Okay. Right. Assert. If the ref is less than 1, panic. Huh. It's less than 1, panic. Assert that it's greater than or equal to 1. If it's less than 1, file close. Yep. If it's not equal to, yep, looks good to me. Last one, kalloc. Sheesh. If. All right. Let's just do it. So assert 0. I'm just gonna try to do it mechanically without really thinking too much about it. And I hope that's right. Okay. Is that right? If the V is not aligned, or the V is less than end, or the V to P is greater than fizstop, panic. So we assert that the thing must be aligned and the thing must be greater than or equal to end. And the V to P must be less than, yeah, looks right to me. Do we build? Nope. I forgot. Assert. Suggested. Oops. Good catch. I forgot. Good catch, compiler. Kimu. Okay, I think I don't even know if touch is a thing. Victor. I wonder actually. Oops. I wonder where the disk is that. Yeah, when I do makedir, what happens? Does it have a file that it created? I haven't seen anything. Yeah. No idea. No idea. Okay, kalloc. What a marathon. So the only things left are things that have side effects, which I was too lazy to extract user space and user space stuff. Good, let's go. So now let's make a commit. Port everything to gdn assert. Except for a few places that had a side effect in the condition, mostly in storage disk code. Let's go. Nice. Yeah, good. Like, that's a solid day's work. Let's make clean, make Kimu, recompile everything, and nice. I would say we can merge that. How do I merge? Merge. Yes, but I want to make sure I'm using merge commits because I like merge commits. Disable fast forward. Merge ff equals false, right? Okay, let me reload here. Merge. Yeah, there we go. All right. All right. Yeah, that was a good day. Wow, that was a good day. I'm going to end the stream here. Thanks a lot for watching, and I will see you next time. Peace.